Okay, so I know that a lot of students struggle with the concept of EAR and APR, so I decided to do an explanation, a video explanation of these concepts, and hopefully this might help a little bit for you to watch a couple times, and maybe that will help clear up some of the problems. So let me start from the beginning and look at some formulas. So we have three formulas when we're talking about EARs and APRs. The first one we can think about is APRs. So an APR for us, not for us, for everybody, is an annual percentage rate. This is the rate that's provided to you by lending institutions. So often our questions we will get the percent in, or our interest rate in APR format. The problem with APRs is that they do not account for compounding. And because we're in a finance class and we very much care about compounding, and you should in your personal life also, we need to adjust that APR that we're given to account for compounding. So an APR is equal to, its formula is the period rate multiplied by M. Okay, what's M? Well, M is the number of compound periods in 1 year. So let's do a couple examples here. So if we have a rate, an APR, with monthly compounding, what is our M? Well, our M is going to be 12 because we have 12 months in a year. What if we have APR with weekly compounding? We have to think about how many weeks we have in a year. We have 52. So we could do this, a couple more times with semi-annual compounding. How many semi-annual periods do we have in a year? Well, there's two. If you split the year in two semis, then we get 2. Okay. So if we can go through and do a couple examples with this APR. So if I give you an APR with monthly compounding equal to, let's say, let's make it simple here, of 12%. Okay, then we can sort out what the period rate is. The period rate here would be a monthly rate, and we can calculate that as 12% divided by 12, because with monthly compounding, our M is going to be 12. So that's an example of APR. We can only manipulate APRs based on the M associated with it. So if I was given an APR with monthly compounding and I was looking for a weekly rate, I could not divide the APR that I'm given by 52. I can only divide it by its M. Okay, so that is APRs. So APRs, not good for us. We need to manipulate them because they are presented to us in a format that does not account for compounding. So one of the interest rates that is useful to us, and especially if we're looking at things on an annual basis, is the EAR. The EAR stands for the effective annual rate. Okay, and it has an association with the APR. We can take an APR and we can annualize it using the EAR formula. So the EAR formula is equal to 1 plus our APR over M to the power M minus 1. Or we could say, because we know that this piece here, this is equal to our period rate, for example, a monthly rate, then I could say This is 1 plus your period rate to the power m minus 1. The same thing. So this becomes really useful because this will provide for us an annual rate that we can use, to solve our problems, to solve the problems that we have in this class, Yeah. So what's an example here? Let's do an example with the one above. Okay, so we've got APR with monthly compounding equal to 12%. I want to know what is the EAR. So the EAR would be calculated as 1 plus the period rate, which we have, I didn't solve through here, but that would be equal to 1%. So 1 plus 1% to the power 12 minus 1. So let me just run that quickly into my calculator. So 1.01 to the power 12 minus 1, 12.6825. So we can note that this rate here will always be higher than the APR. It will always be higher because it accounts for compounding. So that is our effective annual rate. Okay, so the last rate that we have that we sometimes want to solve for is our period rate. And this often is what we need to do whenever we have an interest rate compound frequency that doesn't match the cash flow frequency. So with our period rate, what we can do is we can use the EAR to figure out what it is. And I've shown you in class that there's a formula that you can kind of remember that helps you get there. So if you know the EAR, then we can calculate our period rate. We can calculate as follows. We can say that the period rate, whether that be a monthly rate, a weekly rate, whatever, oh, got that in my head, monthly, a period rate is going to be equal to 1 plus the EAR. Okay, so if we know that EAR, 1 plus the EAR to the power 1 over m minus 1. Okay, this becomes an extremely useful formula for us if we want to take an EAR and move it into a different rate. Okay, so I'm going to do an example now that applies all of this stuff together. So if I have the following situation, okay, I'm given a certain set of variables. I'm given my cash flows that I earn are positive 35,000. What am I going to do here? Let's say per month. I also know that my interest rate that I earn on the account that I'm going to put that money in is equal to a quoted rate of 5% compounded semi-annually. I also know that the term of these cash flows is going to be 5 years. And that's enough information. Okay. Excuse me. So what we need to think about is matching everything to our cash flows. This is our anchor variable because we cannot manipulate cash flows. So if cash flows come per month, I need all of my other variables expressed in months. So this one here is pretty easy. Years, all we need to do is 5 times 12. So no problem there. But we need to do a little bit of work on our interest rate to be able to move it into a monthly rate. So we need a monthly rate. And remember, that's a period rate. Okay, so how do we do it? Well, we're given an APR equal to 5%, and that's with semi-annual compounding. So we know that the M is equal to 2 in that case. And so what I want to do, first step, is to find my EAR. Okay, I want to get rid of the effect of this APR, move it into an annual rate that's actually useful to us. So I use my formula for the EAR, 1 plus the APR divided by the M to the power M minus 1. So if I run that into my calculator, that's going to give me 5.0625%. Now, I can't stop there. If my cash flows were annual, then I could stop there, but I can't stop there because I'm looking for a monthly rate. To find a monthly rate, I'm going to employ this formula that I have up here, my period rate formula. 1 plus the EAR to the power 1 over M minus 1. Now, you're going to note that the M in this phase of the question here was equal to 2. Because we had an APR that had a compound period of semi-annual. Now in this step, we're looking for a monthly rate, so now the M is going to be 12. So let's substitute in our numbers. So 1.06025 to the power 1 over 12 minus 1. I'm just going to run this into my calculator quickly. So the solution is 0.004129, or I could say, 0.41239% per month. And then I can use that to solve for either the present value or future value of my cash flows. So if I wanted to go ahead and do that, find the present value of the cash flows, I'll use my calculator inputs on this one. So I've got payment is equal to 35,000. I've got IY is equal to 0.41239. What else do I have here? And then I've got my N is equal to 60, and I'm going to compute PV. Okay, so that kind of sums up what I wanted to go over for APR and EAR. Very important though, guys, that you do understand this because it definitely comes in throughout the course. It's really getting a handle on what each of these three types of rates mean.